Raman spectroscopy has a long history. In the 1920s, Chandrasekhar Raman was studying light diffusion through liquids, and he discovered that the light passing through the liquid would generate these little sidebands on the light, little tiny signals that could be measured. And he also discovered that those little signals were related to the particular molecules that were in the liquid. This kind of work is called Raman spectroscopy, measuring those little sidebands on the light.
And since that time, Raman spectroscopy has been a staple of chemistry and physics to determine molecules in samples. So you can identify trace amounts of materials or molecules in a material.
So years ago, and it hasn't been that long, the only people that actually used Raman spectroscopy were people who were trying to get a PhD in physics or chemistry. And one of the great things about the scanner project is we figured out how to build an instrument so that the layman can do Raman spectroscopy and get reliable, repeatable measurements without having to have a PhD in science. One of the things that's great about measuring carotenoids in skin tissue is that the carotenoids, beta-carotene in particular, has this property where blue light excites the upper state of the molecular transition, but that upper state is quenched into vibrational modes, and so you don't get a great deal of fluorescence from the beta-carotene itself. But instead, what you get is a strong Raman signal without the confounding background signal from the beta-carotene. And so S2 was a new design where we could use LEDs instead of a laser. We could use photomultiplier tubes instead of a spectrometer to try and measure these very weak signals. And we're able to make measurements that are independent of the temperature, independent of the humidity, things we can make machines that are accurate so that if you measure the same sample repeatedly on the same machine, you get the same answer to within about 5 or 10%. And if you measure the same sample across 10 different machines, you get the same answer to within about 5 or 10%.
So we have a high level of confidence in the integrity of Nu Skin, especially as they've pushed us to try to make sure that the measurements are accurate. And as we experienced difficulties, they kept saying, let's take the time to do this right. Let's put the resources in to really solve these problems and discover what's causing this variability. And inevitably, we're able to chase these problems down and make the scanner exactly how they need it.
I'd say there's no doubt that we can measure carotenoids using Raman spectroscopy. We've done it in our own lab using beakers. We've made samples that are rich in antioxidants, and we've measured the Raman signals directly from that. We've seen this over and over again. The ability to use Raman spectroscopy to measure carotenoids in human skin, I would say, is bulletproof.